Hi guys, this is Navin again. So our topic will be machines. From today we'll be learning or we'll be dealing about machines. An electrical machine is an apparatus that converts electrical energy into mechanical energy, or it utilizes electrical and mechanical energy to convert into electrical energy, or it regulates my AC voltage. Alright, the basic requirements of a machine, or basic requirements what we need to understand about a machine to appreciate its concept is Faraday's law of electromagnetism. What does Faraday's laws of electromagnetism says? Faraday's law explains that, or it says that whenever there is a relative space variation or a relative time variation between my magnetic field and electrical conductors or conductors, EMF will be induced in it. Alright, so the basic requirements, what we can conclude from that statement is we need a magnetic field, we need set of conductors, and we need either space variation, relative space variation, or relative time variation. And the second statement what he put forth was thus induced EMF, the thus induced EMF is proportional to the rate of change of flux linkages. It might be either flux linkages or it might be flux linking, which depends upon the relative space variation or relative time variation. And then, what does relative space variation and what does relative time variation infer us, or what do we get from it? Alright, so relative space variations, in the relative space variation, my conductors will be moving and my field will be stationary. Alright, in this, my conductors will be cutting my magnetic field, hence the flux EMF induced in the set of conductors is proportional to the rate of flux cutting, or rate of my conductors cutting the flux. So in the relative space variations, my conductors will be moving, hence as our conductors are moving, it is dynamically induced EMF. This is the most general property of my motors and generators. And relative time variation, in this my magnetic field will be varying. As magnetic field is varying, my conductors will be stationary, and this flux links the conductors in it, and thus induced EMF is proportional to flux linkages, whereas in the case of relative space variation, the flux produced, the EMF produced is proportional to flux cutting. This is called statically induced EMF. As my conductors are stationary, this is a statically induced EMF. This is the most important property in my transformers. Then, now let us understand more about relative space variation or relative time variation or statically induced EMF, dynamically induced EMF. When we know about it, we can really appreciate the concept of machines. We can really understand, we can really enjoy the concept of machines when we understand about statically induced EMF and dynamically induced EMF. Now, as I have already discussed about relative space variation, as I have already mentioned about relative space variation and relative time variation, now let us understand the concept of relative space variation and relative time variation, from which we will appreciate the concept of machines. As I have already said, relative space variation, in the relative space variation, my conductors will be varying with space. That means my conductors will be in motion, and the EMF induced in the conductors depends upon flux cutting action, because my conductors will be moving and my magnetic field is constant. My conductors will cut my magnetic field. As a result, EMF will be induced in my conductors. Alright, now the direction of this induced EMF can be understood from the following explanation. Now, consider a conductor placed in a magnetic field. Let B is the magnetic field density and L is the length of the conductors. As I have already said, in relative space variation, velocity or the motion of conductors are very important. Let V be the velocity, and we all know that magnetic field density and velocity are vectors. And we have a basic knowledge that EMF induced is equal to BLD sin theta whenever a conductor is placed in the magnetic field, and as B and V are vectors, it gives me my vector product or cross product, which results in an EMF vector. This n cap here infers that my produced EMF or my induced EMF will be perpendicular to the plane containing my magnetic field density and the velocity vector. Now, we all might have confused at any one point in finding the direction of EMF in a motor or in a generator. we use lot of tricks, lot of techniques to remember the Fleming's right hand or left hand rule. I have a more simpler one in order to make you remember most. See, in the most easier part of remembering a formula or remembering the direction principle or something is to understand why this principle has come from or from where the principle has come from. Okay, now consider three mutually perpendicular planes or x, y, z planes what we could easily find from our hands. Place your fingers, thumb, index finger and middle finger in such a way that these three are mutually perpendicular to each other. Now for easier understanding I have put it on board. Alright, now let my x represent my index finger and y axis represent my thumb finger and z axis represent my middle finger. Okay, then now as we all know that for production of electrical energy, the generator principle, we have a clear idea about it, where my mechanical energy will be converted into electrical energy. Alright, now as mechanical energy is being converted into electrical energy, there requires a medium that links these both, and that medium is magnetic energy. Remember the principle, mechanical energy being converted into magnetic energy first, magnetic energy converted into electrical energy next. Alright, now if I take my thumb as mechanical energy or motion of the conductors, okay, motion of the conductors, and if I take magnetic energy as my index finger, and if I take my current or electrical energy as my middle finger, we can easily understand it, because electrical energy or my mechanical energy requires magnetic energy to be converted as electrical energy. In this way we can easily remember this Fleming's left hand rule or right hand rule, both means the same. Left hand rule will be applied for motors and right hand rule for generators. Another way of remembering which rule for which machine, we all have an idea about manufacturing company, automobile manufacturing company LML. Okay, remember LML, left hand for motor, LML, LM for left, L for left, M for motor. So apply this left hand principle for motors and right hand principle for generators. I am explaining it once again. The motion of the conductors, okay, the motion of the conductors is indicated by my thumb finger and my magnetic lines by index finger, and my middle finger indicates the electrical energy. My mechanical energy requires a magnetic field or magnetic medium to get converted into my electrical energy. As a result, so my electrical energy is produced from my mechanical energy. So thus from this explanation we can easily remember or we can easily find the direction of my induced EMF either in a motor or in generator. Alright. Let us go into relative time variation, where my conductors will be stationary and my magnetic field will be varying with respect to time. So in this, as my conductors are stationary, the EMF induced in my conductors mostly or only depends upon flux linkages, as this is my conductor and my magnetic field links with it, or my magnetic flux links with these conductors, and according to Faraday's principle, because of relative time variation between magnetic field and electrical field or conductors, relative time variation between magnetic field and conductors, EMF is induced, and thus induced EMF is called statically induced EMF. It is the main concept in transformers. In all transformers, the EMF induced is statically induced EMF. Now, in order to understand, in order to know about the direction of thus induced statical EMF, consider this ball metal bar. Okay, when it is energized by an alternating source, because in alternating source my current will be varying and the flux which is produced by this current is also varying in nature. Okay, and this flux links with my metal bar. Okay, now applying inverse to Ampere's corkscrew rule, inverse of corkscrew rule says that my thumb indicates the direction of magnetic field, or my thumb indicates the magnetic pole and my other fingers indicates the movement of current or the flowing of current in my conductor. As I have shown the conductors to be flowing upward direction, using this principle my thumb shows north rule, leaving out from this electrical bar and will be entering at this end. As we all know, in a bar magnet, at the north pole of my bar magnet, magnetic lines of force will be leaving and will be entering into the bar magnet in my south pole. In this way, north and south pole are formed. Because of this flux linking, EMF will be induced in it. And we all know, according to in nature, whenever a force is applied on an object, it shows some amount of resistance. This is explained as below. See, whenever someone beats you, you offer a resistance to him. You offer a force in opposition to that force applied by him. Alright. Whenever you hit onto a substance, it offers some amount of resistance. In the same way, you are applying some amount of force on my magnet, that is my electrical field, okay, or that is my magnetic field, whatever you can take, and something is induced in it or something is formed in it, and thus formed EMF or thus formed some phenomenon will be in such a way that it has to oppose the force that is being acting upon it. Okay, I mean, this magnetic field which is responsible for my EMF is the force which is responsible for the production of this EMF. This EMF will be induced in such a way that it opposes my magnetic field. Alright, this can be seen from this. As I've already said, my magnetic flux is varying, and according to Faraday's law, Faraday's second statement, induced EMF is proportional to either rate of change of flux cutting or flux linkages. EMF is proportional to rate of change of flux according to Faraday's second law, and induced EMF will be opposite to my flux linkages. Alright, this is from these two statements what we can infer is E is equal to minus n d phi by dt, where n is the turns of a conductor. Alright, now this is what relative time variation says. And relative time variation says that my conductor here is stationary and my magnetic field is alternating in nature. From this setup we can understand that as magnetic field is varying, EMF will be induced in it, and according to Lenz's law or according to the property of nature, whenever a force is being acted upon an object or substance, it produces some opposition to it in order to suppress this force, in order to handle this force. In the same way, whenever a cause is producing an effect, this effect will be induced, or this effect will be in the direction in such a way that it opposes the rate of change of cause. Alright, here my effect is EMF and my cause is magnetic field. In this way, we can understand about relative time variations. In the next coming videos, we will go more into this relative time variation, which is an important concept in understanding our transformers, which is our first machine what we are going to deal with. Thank you. If you like this video, subscribe for smart students.